Hello, my dear students. I hope you all have been doing well. Today we are going to start our lecture number 27, and this is about amides. In this lecture, we will be studying about amides part 1. And what is this amide part 1? In this amide part 1, we would be studying about the introduction of amides, classification and types of amides, examples of amides, and we would be also discussing about the physical and chemical properties of amides. So first of all, we will see that what are amides. Amides are actually derivative of carboxylic acid. In that, you know what is the formula of carboxylic acid? Molecular formula CH3COOH. So amide are the derivative of carboxylic acid. In that, one hydroxyl group, that is hydroxyl group, that is CH3COOH, means the last one hydroxyl group is replaced by an amine group. So you have to just keep remember this amide, or we also can say them carboxyamide, are the organic compound or organic molecule. These are the derivative of the carboxylic acid. And how these derivatives are formed. These derivatives are formed from the carboxylic acid when the hydroxyl group of carboxylic acid is replaced by the amine group. So what are derivatives? Derivatives are the compound that are having some differences from the parent compound. So we are saying that amide are the derivative of carboxylic acid. What does it mean? It means that amide form from the carboxylic acid. Carboxylic acid is the parent compound, and amide are formed from the carboxylic acid. How they form? They form by making some changes in the structure of the compound. So what are these changes? If we are having the carboxylic acid, that is a parent molecule, we replace hydroxyl group in from its structure, and in place of hydroxyl group we add their amine group. So the compound that we get finally, we say it the amide, and it is the derivative of the carboxylic acid. So you have just to remember this, that amide are the derivative of carboxylic acid, and amide are having the journal formula, that is RC double bond O N R dash R double dash. So what this formula is indicating? This formula is indicating that amide are having 3 R group. So we can see here in the journal formula of amide, one is R group is here, and one would be here, and one that would be R dash, and one would be here, that will be R double dash. So this is the journal formula or journal structure of amide. So now we are going to see what are the important examples of amide and how they look like. Acetamide, we say also this molecule as a ethonamide. This acetamide, we can see here, it is having a methyl group, a amine group, and a C double bond O group. So our dimethyl formamide, it is also another example of amide. We are having we can see here that this is having a nitrogen atom that is containing 1 2 and 1 2 R group. And then we can see here another example, that is asparagine. And asparagine is the asparagine. What is asparagine? Is a amide, and asparagine is also where you can find the asparagine. Asparagine can be found in the protein. Means asparagine is an amino acid. Okay, and this amino, what are the amino acid? Amino acid are the building block of protein. So this asparagine is an amide, And what are the building block of protein? Means these building block means these smaller amino acid join together and form a chain of the amino acid that we say as polypeptide chain or a peptide chain. And what is this polypeptide chain? It is actually a protein molecule that is made up of a small amino acid residues. So the asparagine is an example of amide, and because it follows the definition of amide, and it is a building block of amino acid. So what are the amide? Amide are the derivative of carboxylic acid, and in that a hydroxyl group replace from by a amine group. So amide can be classified into three main types: primary amides, secondary amides, or tertiary amides. So now we will see how we are classifying them as primary amide or as secondary amide or as tertiary amide. So these amide are classified into three different types on the basis of the carbon atom that is attached to the on the basis of the number of the carbon atom that is attached to the nitrogen or atom of the amine group. So here we can see here that in this case of primary amide, this nitrogen atom of amine group is attached with one carbon atom. If you have to just remember it, if the nitrogen atom in the amine would be attached with the one carbon atom, so we write it or say it or known it as a primary amide. However, in case of secondary amide, if the nitrogen atom of amine group, this is an amine group here, if carbon would not be present here, so this is an H2 group. So here in the case of secondary amine, we can see there this nitrogen atom would be attached with two carbon atom. One carbon atom is here, one carbon atom is here. So this is the secondary amine. And in case of tertiary amine, the nitrogen atom would be attached to the three carbon atom. We can see here one carbon atom, this one two second carbon, and this one is the third carbon atom. So you have to just remember this, that the amide are classified on the basis of the carbon atom that would be attached to the nitrogen atom of the amine group. So this is an H2, this one N having two hydrogen, it is an H2 group, amine group. And this amine group, you can see this in the primary amide, uh, nitrogen is attaching only one carbon atom, and in the secondary amide, nitrogen is attaching with the two carbon atom 1 and 2, and in the tertiary amide, the nitrogen would be attaching to the three carbon atom. So you just have to remember this, amide are classified on the basis of the carbon atom that would be attached with the nitrogen atom of the amine group of amide. Amide is the whole molecule, and it is having this is whole molecule is termed as amide, and the functional group, it is having a functional group that is amine. So you have to make difference in the amine and amide. Amide is the whole molecule and the amine is the functional group that is having that is present in the structure of amide. So now we are seeing that we will be discussing about the physical and chemical properties of amides. Amides are having a higher boiling point because why they are having higher boiling point? Because as you can see here, we are having two amide molecule. So these amide molecule, we can see their structure that are having an amine group and a methyl group, and we can say the carbon atom is bonded to the oxygen atom with double bond. So why the amide having the higher melting point? uh, mm, because this amine group, one hydrogen atom of amine one hydrogen atom of the amine group of this amide is positively charged. So what it would do, it will attract to the with the lone pair uh, lone pair electron of the nearby oxygen atom of another amide. So what happened then? Then there will be a hydrogen at bond that would be formed between two amide group. So between two amide molecule. So you know what is the hydrogen bond? Hydrogen bond is that bond that form between the hydrogen atom and the oxygen atom. Hydrogen atom and the lone pair of nearby oxygen atom. So we can see that the amide molecule is having hydrogen atom in its structure, or it is also having the oxygen atom that is having lone pair of electron. So due to this reason, what happened, that one amide molecule, one hydrogen atom would make the uh, hydrogen bond with the lone pair of oxygen atom of the nearby amide molecule. So due to this hydrogen bonding, the amide molecule are having, or amide compound are having higher melting point, means they will be having energy for their melting, or to break out this bond, hydrogen bond. So another physical property that we would discuss about the amide is their smell. So the amide are having characteristic, means smell. So for example, ethanamide actually is acetamide. Acetamide is another name of ethanamide, and here we are having the structure of ethanamide. You can see here it is having a carbon atom that is double bonded with oxygen atom, and it is having a methyl group, and it is having an amine group. This is the structure of ethanamide. And what would happen, this ethanamide is having um, means smell. So how we would discuss it here? Why? Because this ethanamide, what happened, it is having two hydrogen atom in amine group. So what would happen, this one hydrogen atom replaced by a methyl group. So the compound that we get after the replacement of one hydrogen atom by this methyl group, we said that this methyl group is added in this ethanamide as an impurity. So this molecule would transform from ethanamide to N-methyl ethanamide. So this N-methyl ethanamide molecule is having characteristic, means smell. So this smell is why, due to the having of this methyl group. So you have to just remember this, that amide, some amide, for example, N-methyl ethanamide is this is an amide. N-methyl ethanamide is an amide, and it is having characteristic, means smell. Why this N-methyl ethanamide is having characteristic means smell? Because it is formed from this ethanamide by replacement of one hydrogen atom by the methyl group. So this N-methyl ethanamide, this is having this formula. We can see here that the one hydrogen atom, it is having only one hydrogen attached to the nitrogen, and one hydrogen is replaced by this methyl group. So this N-methyl ethanamide it, that is formed from ethanamide is having characteristic, means smell, because of the having one methyl group that we considered as this is an impurity. Because what is this impurity means, this add in this ethanamide molecule, that is not would not be necessary, but it adds in this ethanamide molecule, that was the parent molecule, and this it transform this parent molecule from ethanamide to N-methyl ethanamide, and this N-methyl ethanamide is having characteristic, means smell. So this would was the one important or characteristic of ethanamide. And then other is the their physical appearance. So you can remember on your fingertip, amide are having high boiling melting point, amide are having characteristic mince smell, amide are deliquescent in their nature, and they melt at with 82 degrees centigrade. So what is deliquescent? Deliquescent are all those, this is a property, deliquescent compound are those compound that can absorb moisture from the environment, and they dissolve themselves in that moisture. So all those compounds that are exhibiting such type of property, so they can absorb um, moisture from the environment, and dissolve themselves in that moisture. We term the all these compound that these are the deliquescent compound. So amide are particularly one type of amide, that is ethanamide. And what is ethanamide? That acetamide. Acetamide is an ethanamide, means it is an amide, and it is having the ability of absorb moisture from the air and or in the environment or the atmosphere, and then dissolve itself in that moisture. um, and this phenomena is say that we say that deliquescency, and then these ethanamide is the deliquescent in nature, and it is also colorless in its appearance. However, the crystals of ethanamide would be melt at 82 degrees centigrade. So another important physical property of amide are they soluble uh, in water, uh, because they are having the ability to make hydrogen bond with the water molecule. So in my previous lecture I many time explain you what is the solubility. Solubility means the process of making hydrogen bond with the water. When a compound atoms make hydrogen bond with the water atoms of water molecule, so we say that it is soluble in the water. So amide are as I discussed in my previous slide, here we can see that amide can make hydrogen bond. Amide can make hydrogen bond with another amide molecule. So how it is making hydrogen bond with other amide molecule? Because amide is having uh, an amine group that is having a hydrogen atom that is positively charged, and this hydrogen atom can attract negatively charged oxygen atom that is having lone pair of electron. So this was the case of two molecules that are both amide. But when we see the formula of water, so what is the formula of water? H2O. So it means the water is also having an oxygen atom, and this oxygen atom of water is having lone pair of electron. So what would happen when we mix the amide molecule with the water molecule? The amide molecule, you know, it is having an amine group that is having NH2, and means one nitrogen and two hydrogen atom. So the one hydrogen atom of amide that is positively charged would make the hydrogen atom with the water molecule oxygen atom that is having a lone pair of electron. So by this way amide would be dissolved in water or soluble in water, but it needs energy to break the hydrogen bond between amide molecule and between water molecule before they can mix. And but enough energy is released again when the new hydrogen bond are set up to allow this to happen. So when means this breaking and making the hydrogen bond between the water molecule and the between the amide molecule, that we say that it is soluble in water, this breaking and making the hydrogen bond need energy. You have to just keep in your mind that amide molecule are soluble in water. Why these are soluble? Because they are having a positively charged amide molecule, having a positively charged hydrogen atom that would make hydrogen bond with the lone pair of electron of the oxygen atom of water molecule. You just have to keep it in your mind. And now the next we are discussing the chemical properties of amide. So the one of the most important chemical property that we are going to discuss under the heading of amide is the hydrolysis. Amide means hydrolyze in water after extreme difficulty, means they resist hydrolysis in plain water in even after prolonged heating, means if we dissolve amide in water and and heat them, even after heating they would not like to dissolve, or they would not like to hydrolyze in the water. But in the presence of acid or base, hydrolysis proceed at a moderate rate, means amide cannot easily hydrolyze in the plain water. And if we add the acid or base in the water solution for their hydrolysis, so they moderately hydrolyze, not completely hydrolyze. However, in the living system, means in our body or in our body cell, the amide hydrolysis takes place in the presence of an enzyme. What are enzyme? Enzyme are the catalysts that uh, speed up the reaction, chemical reaction. So you have to keep in your mind that amide cannot easily hydrolyze in the plain water. They can be partially or moderately hydrolyzed in the presence of acid or base. However, in our body, I am talking it about the outside the body. In outside of the body, amide, when we are having, for example, amide in a test tube, and we are putting the pouring the water in the amide solution, what will be happen? Amide would not dissolve or would not hydrolyze. And if we add some acid or base in the test tube that is containing the amide and the water, so the amide would get partially or moderately hydrolyzed. But if the amide would be present in our body or in our body cell, so what would happen? In our body cell there are various enzymes that would be present in our body cell and will help amide hydrolysis, will help in amide hydrolysis. So the what are these enzymes? These are enzymes are actually the catalysts that speed up the reaction. So, and what is the process of hydrolysis? Actually, hydrolysis is the addition of water in a double bond, means in a molecule. So we can see here what happened. We are having a amide, and we are if we want that this amide would be add with a water molecule. So what we would be having, we will be having an enzyme, and what this enzyme will do? This enzyme will assist this water molecule to add up in this amide. So we can see here what will be happen then by the help of this enzyme. This one hydro what is the molecular formula of water? H2O, means it is having two hydrogen atom and one oxygen atom. So with the help of enzyme, what happened? One hydroxyl group is add up in this molecule, and one nitrogen removed from here, and one nitrogen from here, and two hydrogen from here, and one hydrogen from here, make this ammonia or amine. So now we see this hydrolysis of an amide in acidic solution actually give us a carboxylic acid and the salt of ammonia or an amine. However, if we do this hydrolysis of amide in the presence of basic solution or base, so this hydrolysis give us a salt of carboxylic acid and ammonia or an amine. So you have to keep in mind, just I am summing up here, I am concluding here about the hydrolysis of amide. You have to keep 2 3 point in your you have to keep remember 2 3 point in your on your fingertip. One, I'm talking about the outside environment of our cell or outside the body. In the environment, how in the plain water the amide would resist hydrolysis, but if we use some acid or base, they moderately or partially hydrolyze. But in our body, amide would need enzyme for its hydrolysis, although they hydrolyze, but they need enzyme. And here this the reaction that I be showing here, I'm showing here, this is the reaction that is takes place in our body, means it is showing here enzyme. And I explain you that in the our body, in our body cell, the amide hydrolysis need enzyme. So, dear students, this was the lecture, today's lecture. And for further information, we are you can also go to through this link. We can you can also read the book IL Finer, and then thank you very much for your kind attention. And this was the full lecture, and then we would be studying about the amide part 2 in my lecture number 28. And then in amide part 2 we are going to study about synthesis of amide, and then we would be studying about how we identify the amide, and then we would be studying about the application of amide. So thank you very much again, and thank you very much for your kind attention.